off we go. So let's pick back up where we were. We're talking about Python. The rest of this is going to be about Python because we have a little bit more to cover. So here's my idea. Let's remember functions with a function that encrypts something. So remember that encryption is just like garbling something so that you can like give it to somebody and like have them not catch what you're saying, but somebody else can decrypt it if they know the key. So a simple kind of encryption was this ROT13 thing that we talked about, also called the Caesar cipher. It's just shift every character of the alphabet by 13. Like A becomes N, B becomes O, and then vice versa, wrap it around. It's like O becomes B, P becomes C, all that fun stuff. And that is your encryption. And the beauty of the Caesar cipher is if you just do it twice, hello becomes Uryib, something weird looking. But if you do ROT13 on this again, it is its own inverse, so it brings you back to hello. So it's not the most, not the best form of encryption, but it's an easy one to do. And maybe it tricked people back in the BC era, in Caesar's time or something. So let's make a function that does this. A function that encrypts a string, and we'll go from there. Let's see, I need to be an idle, that's for sure. And let's see, I already made a folder for today. I just got to get us there. So I'll make a new file, and I will save it as rot13.py in my desktop in the most recent folder, which I just made right now, lecture 32. Cool. So that's what we're going to do. And here is the setup. We want to do something like this. We want to get some, like a string from the user so that we can encrypt it. So it'll be like input, enter your super secret string you want to encrypt. Enter a string to encrypt. And let's to make it easy on ourselves, let's do it just like this picture. So let's make it encrypt only capital letters. So we'll ask the user for a string consisting only of capital letters, please. All caps. And then we'll get that into a string, and we'll call that string text. It's the text we want to encrypt. And then let's make a function called rot13 and have it like work on that text and encrypt it, and we'll print out the encrypted form. Okay, so that's the beauty of it. That's how it's going to work. And I think I'm going to change this name because there's kind of two ROT13s, right? There's I would like to do the Caesar cipher on an entire string of characters on my text. And then I'd also like to do the Caesar cipher on an individual character, right? Because I want to do that a bunch of times for each character in the initial string. So it's like ROT13 string, ROT13 character. So let's do it that way. I think that would make it easier in my mind to make it make more sense. So I want to do ROT13 on a whole string, which will be made up of doing that on individual characters. Right? That's the name of the function that I'm going to make it. So there's that. And yes, we're going to need two functions. One to encrypt a single character, and then one to encrypt an entire string. Okay? So the goal is to go from like this this text to all caps hello. If you pass that to our function, we would like that to go to like a new encrypted string that will return back. We want to build it up. Encrypted string, and that will become the Uryib, and we'll go like, look at the H, put it there. Make it a U, encrypt the character. Look at the E, figure out that it matches to an R, so encrypt the character. Uryib, and we'll build up this string a character at a time. And then that's what we'll return back to the user from this function. Okay, so let's do that. Let's pretend we have the ability to ROT13 a single character. Let's define the ROT13 string function. Here's how you do it. So you make a function. You say def, give it a name, and then between parentheses you give comma separated as many parameters as you need, things that you'll be giving as arguments into these, or will be fed into these when you call your function. Some functions don't need any parameters, but ours, the one that we're about to make, it needs one because it's got to take this argument. I'm going to say what we're trying to encrypt. And then you put a colon, look for the sad face, and then you indent and you give the body of your function all the things that you need to do to get that thing done. Some functions need to return stuff. Our function will need to return stuff. Give back our encrypted string. But some functions just print stuff out. And so that's how that works. And then to call your function after you made it, like you say its name, you give it arguments for every position that it has parameters. And it's going to go and it's going to run this function. It's going to jump up here, start running the body with param1 set to arg1 and param2 set to arg2 and so on and so forth. All right, it's going to start running the body with those things set. And if your function gives something back, you can get it back. Things that are returned will be saved. Functions that don't return anything, you don't put this part. Okay, so don't forget to save that result or just use it if it gives something back. So that's the setup. So let's define a new rot13 string function. And then we'll use that to encrypt this entire string, every character in the string. So def rot13 string, give it the text. So it's going to take some string s, or some string called text, and so text will be passed into another variable called text. Why not? And what we want to do is build up this encrypted string a character at a time. So I want to go through every character of text and build up, find its encrypted form and add it to the encrypted string. So I'll start off an encrypted string variable empty. So I want to go through all the characters of text. Oops, not yet. I want to go through all the characters of text and add it one at a time. Add the encrypted version of that character one at a time to encrypted string. So yeah, this is the setup. Go through every character in text and encrypt it. Add it to the encrypted string as well. So here's how you go through every character of a string. You think of it as a list of characters. So you can use a for loop on it. You can be for every character, call it C, in that text string. And C will have a chance at being every individual character of text. That's beautiful. So for the first one, I want to encrypt it. So what's the encrypted form of this character? So this character C. I don't know. It's I gotta do this thing, right? But let's wait. Let's just pretend we have that ability. We'll deal with that later. So let's pretend we have a function called rot13, a single character. If I give C and it gives back their encrypted version, that would solve my problem right now. Just wishful thinking. Okay, this is how we program, just from the top down. And then okay, we have that encrypted character. We've got to add it now to our encrypted string. Right? That's the new thing. It's like the U. Then we'll add the R, the Y, the Y, the B. All right, one at a time. So take what your encrypted string was, encrypted string, take what it was, maybe it's empty and we just found the U to add that new character to the end of it. So maybe this was the first character, we're trying to encrypt the H. C was H, so we got a U out of this, and then we want to take the string and make it have U at the start. So add that U to the end of it, which is also the beginning if the string starts out empty. And then the next round, it's the E, C is E, it'll be encrypted to R, and then we'll add to our string one character, we'll add the R to the end. It was U already, now it's UR. Does that kind of make sense how it's going to build it up? If only we had this function that did a single character encryption thing. Because that's really the last piece of the puzzle. Now, if we just had this to encrypt a single character, return its encrypted form, we have our answer. So let's make that. Def rot13 char on a single character C, and then this is where it gets a little complicated. There's a bunch of different ways to do this translation process, but the easiest way in my mind is let's make two lists of characters, or that is, let's make two strings. Call it chars and encrypted chars. I'll make chars, a string called chars, and it will have all the letters of the alphabet. All right, I promise I'm going somewhere with this. It'll have A, then B, then C, then D, then E. It'll have all the characters of the alphabet, E, F, in order. And then I'm going to make another string called encrypted chars, and I'll use it to look up. I'll use chars to look up in encrypted chars, because every corresponding index, right, this is index 0, 1, 2, 3, 4, 5, etc. I'll have the same thing underneath in this new string that's form. So A, the encrypted form of A is N. So I'm going to put N first in encrypted chars. Do you see the game I'm playing here? N, O, P, Q, R. I'll do this for every character, all 26 of them. give their encrypted form. So here's what we could do. Let's say we're trying to encrypt the E. We're going through hello. What we do is we find the E in chars, figure out its index 4, and then go to that same index in the encrypted char string, and that will give us the encrypted character. See that? So that's one way to do it. And that will be our method of the day. Like, go here, find your E, and be like, oh, same index. Go to the same index in encrypted chars, you found your encrypted form. So I'm going to make 2 strings now. Chars is the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And then encrypted chars, it's gonna line up. So let's try and put this in order. And then it wraps around. It's going to be N, O, P, Q, R, S, T. Now I really can't mess up. U, V, W, X, Y, Z. That should be M. Cool. A, B, C, D, E, F, G, H, I, J, K, L, M. Yay. So that seems to work. So the idea is we're like, all right, you find an H, go to the same index, like find H. You're trying to encrypt H. Go find its index in chars, and then go to the same index in encrypted chars. You found the encrypted version. That makes sense. So that's the name of the game. So find the index of C in chars. That's the first thing we need to do. So we have to go through all of chars looking for this character C that we were given. So maybe it's H. So start at index 0. That's the first place it could have been. And then we're going to give back. We want to find the index of that character. All right. And we don't have a value for that yet. We can be like question mark -1. But we want to go through all of chars looking for C. And hopefully we'll eventually find it. Okay. So we have to loop. While I is less than the length of chars, like it's an index still, goes from 0 to the length -1. And then if I find that chars of I, where I'm sitting right now, where I is looking, if that's equal to that C, then I know where the index is now. It's right here. Index of char, like that was the H. It's equal to I. I found it. Save that. And then be like I equals I plus 1 because it might not have found it. And so we'll go through all of chars looking for the character we're trying to encrypt. Eventually we'll find it, hopefully. And we'll set index of char to something that's not -1. And then we go to that same place. Go to that same index in encrypted chars. And return that. Return encrypted chars. Go there to that same index. Give me back that character, please. At index of char. Right. That's the thing. Like we're trying to encrypt H. We go and we search through I equals 0, 1, 2, 3, all the way to whatever index of H that is. And then we save that away. We found it. Like it's going to be set. And then we go to that same index in encrypted chars. There's your encrypted character. And we're going to do that for every character in our original string. And that's why we needed 2 functions. And so enter a string to encrypt. Oh, wait, I don't like the way I did that. Let's do colon space. Excuse me. Rerun. We'll do hello, all caps. And, oh no, it's none. What did I forget to do? I forgot to return the encrypted string at the end of this function. I'm supposed to give it back. You're just building it up and not giving it back. So there, now it's giving it back. I think that is everything. Uryib, sweet. And you give it again, and it will decrypt it. Uryib goes back to hello. So it's a complicated idea, but functions made it easy. Like we pretended that we had some things, like when we wanted to use this. And we're like, all right, what else do we need? Pretend that we had this, and then we made it. Just that's kind of how you do it when you're programming stuff. Think about what you need, pretend you have it, and then go make it. So yeah. Any questions about this example? That's functions. These are functions that return something, giving stuff back. Like we're taking that answer here, and we're also taking the answer here so we can immediately print it. That's that one. What next? I would like to do, let's talk about randomness. So don't forget the random library, it's beautiful. I would like to make for our first program, let's make a random Etch-a-Sketch program. We all seen what Etch-a-Sketches are? Like it's part of my childhood. Do you guys still have them? It's a little thing with a window and it's got knobs, right? And you turn the knobs and it draws straight lines unless like you turn both at the same time. And then you shake it once you're done. So that's an Etch-a-Sketch, right? Hopefully we've all seen that. And so let's make a turtle version of that. So we'll have the turtle draw a bunch of random lines and like turn in random directions, random multiples of 90 degrees. Yeah. So that could be our little program. And so let's make an Etch-a-Sketch program. The turtle's going to start in the middle, and we'll have the turtle like pick a random direction and go a random amount, and then turn by a random amount too. Just repeatedly do that a bunch of times, forever and ever and ever, until maybe the turtle goes outside of some window. And so let's say that like if the turtle ever runs outside of a 600 by 600 window, like we want to keep him within this range, then we'll stop him, because he could go on all day. So like if he ever gets outside of like, this is what, 300, 300, and this is negative 300, bound him somehow. And then if he wants to stay within there, he can have fun all day long, but eventually he'll go outside of the bounds, all right? So that's going to be our first program. So let's remember randomness, the random library, and also the turtle library. So this will be actually pretty quick, just fun to think about. So I'll make a new file. I'll call it etch-a-sketch.py. And so I'll include, oh gosh, I hope I didn't click that button. I'll import my two libraries that I need. I need the turtle library to draw stuff, turtle, and I want the random library as well to have the turtle do cool stuff. So turtle.shape, we like turtle-shaped turtles, and then also turtle.speed. We're going to do a lot of stuff, so let's just have him go as fast as he can. So, yeah, let's be like, I don't know, let's have an infinite loop right now. We'll fix that later. But what do I want to do forever? I would like to have the turtle go forward by a random amount within some range, and then also turn by a random multiple of 90 degrees, so create like hard lines. And so let's program both of those things. How do you make the turtle go forward by a random amount? You say turtle.forward, and then you give a random amount in here. So random.randint, let's say, between, I don't know, 10 and 50, some amount like that. So anywhere within there, little short lines or longer lines, go forward by that random amount, Mr. Turtle. And then also turn by a random multiple of 90 degrees. I could say turtle.left or turtle.right here, because we're gonna get every possibility of 90 degrees. So it doesn't matter left or right. He'll have the ability to go up, down, left, or right, depending on what random number we pick here. So random.randint, you can go like 0 times 90 or 3 times 90, all the way from 0 degrees or 270 degrees. Those are all the different possible directions, up, down, left, and right, depending on where you were going. And so, yeah, just do that forever. Does that make sense? Random library. So turn left by this random multiple of 90 degrees, either 0, 90, 180, or 270. So he does have the opportunity to keep going straight if he wants to. It's a quarter chance of that. So there he goes. Whee! Look at him. And now he's outside the window, and that's kind of not fun. He's just never going to stop. So let's stop him. Let's stop him when he gets outside of like 300 by 300 rectangle. And so we can check where the turtle is and get his x-coordinate and y-coordinate with some functions. So Python turtle. Whee. I think it's yeah. You can ask the turtle where he is with turtle.pause, turtle.position. You can also just get individual coordinates with x-core and y-core. So turtle.x-core gives back the turtle's x-coordinate. Turtle.y-core gives back the turtle's y-coordinate. So we kind of just want the turtle to keep going while your x-core is like between negative 300 and positive 300. So you can say this. You can give this kind of math-like combination of less than and greater than to Python. It's happy with that. Other languages, you can't do this, sadly, if you've learned C++. That's not allowed, but this is totally allowed in Python. So while that's true about x-coordinates, and then also we want the same thing to be true about y-coordinates, that'll keep them within a square. So while that's still true, go crazy, Mr. Turtle. Otherwise, we're going to stop you. That'll stop the loop. If he ever goes outside of that range, this is going to keep him within a 300 by 300 square. If he ever goes outside of that square, it will finally stop the drawing. So there he goes, and then he stopped immediately because like he wanted to go up. really fast. But this is like different every time. It's like a random Etch-a-Sketch. So very cool abstract art if you run this long enough, I guess. Yay. So that's just fun to play with, I would say. Are there any questions about how we made this? Not a lot of lines, but we get something cool out of it. That one. So that's turtle plus randomness. I have another one that's just about randomness. This is a fun idea. So this is a more mathy idea. I like it a lot. So here, let's approximate pi. Let's make a program that approximates pi, not very well, to like just a few decimal places, but it's a really fun idea. All right, there's a way to approximate pi by throwing darts at a dartboard. Let me explain that to you. So let's say that we have a square dartboard, and I got to be very specific about how I do this. Let's say we have a square dartboard. But really a dartboard's a circle, right? So let's start with a circular dartboard. But you're allowed to throw it anywhere within a bounding square. That's the game. So pretend that's a perfect circle. See if I can try that again. That's slightly better. So, okay, there is a radius 1 circle. All right, and then let's bound that with a square. Boop. Just touching it. So that's a 2 by 2 square, exactly touching that circle. Yeah. It's touching it down here too, sorry. So that makes a 2 by 2 square that's bounding this radius 1 circle. And let's pretend that you throw darts randomly, like with a blindfold on. And your darts will always, you're good enough that your darts will always hit somewhere within this square, but not necessarily within the circle. All right? The idea is if you throw enough darts randomly, like some will hit here, some will hit over here, like if they can only land within the square, right? They can't go outside the square. Your random darts will sometimes be in the circle and sometimes not be in the circle. Okay? If you do it randomly, that's what's going to happen. And then what is the probability that your randomly thrown dart landed in the circle? Well, it just has to do with how much space was the circle versus the rest of the room that you could have thrown this dart. It has to do with the areas it's the proportion of the area to the circle, area of the circle versus the area of the whole square. Right? Because that's how likely it would end there because there's a lot of circle. Okay? So, yeah. The idea is this ratio, if you divide the number of darts that hit inside the circle by the number of darts that you threw in total, because some of them didn't land in the circle, then that gives you pi over 4 because what is the area of the circle? That's pi r squared, so pi times 1 squared, which is just pi. And then what's the area of this entire square that you could have thrown darts in? It is 2 squared equals 4. So the ratio of how often would your randomly thrown darts end up in this circle, it's, well, the area of this divided by the area of the whole thing. So it's pi over 4. Isn't that fun? And then, all right, that will give you an approximation of pi over 4 if you just throw random darts and you count them. And you make that ratio. If you just multiply that by 4, of course, that'll give you an approximation of pi. It's not the best approximation, but it's so fun. Let me program that to you. I hope that makes at least a little bit of sense. So just throw random darts at a dartboard. You will approximate pi if you keep track. You just keep counting. So darts.pi, import random. I will not draw the darts with the turtle. We'll simulate this. Okay. So import random, and let's throw a lot of darts. So total darts. Let's throw 1,000,000 darts at this dartboard. There. And then we want to keep track of how many darts landed inside the circle. Darts inside circle. Yeah? Equals 0. And so I just want to loop that many times, total darts times, 1,000,000 times, and throw a dart randomly. So for I in range, total darts. Just make this loop exactly that many times. So I'm not even going to use I. So I want to repeatedly throw a dart and then see if it landed in the circle. So I can use the random library to throw a dart. All I really need is the coordinates of where that dart landed, right? It's going to be between, somewhere within this square, so between -1 and +1 on the x, and then -1 and +1 on the y. So that's how we'll come up with that. The random library lets you get random numbers with decimals. Random with not the random.randint, of course, that wouldn't work, but it's random.uniform. There it is. It gives you a random float between a range. So I just want a random number for my x-coordinate between -1 and +1, and then same for my y-coordinate, a random number that's a float between -1 and +1. And that will give me somewhere within that square, sometimes within the circle too. So throw a dart. I get my x and y. So x equals random.uniform between -1, -1.0, why not, and 1.0. And then we'll do the same for y. Oops. No, it didn't copy, sorry. Copy, paste. So there, I've got my x and y now, and I forgot a comma. Oops. 2 arguments to uniform. And then, see if it landed within the circle. We gotta do some math. How do you know if your xy coordinate was within a radius 1 circle? Well, it has to do with the definition of a circle, right? We know, like this, I don't know, let me use green. We know that this dot is within this circle because if you take the distance from the dot to the center of the circle, which is just 0, 0, it's less than the radius, less than or equal to the radius. Like this dot is right on the edge. Let's consider that on the circle too. You just look at the dot, look at the dart, and then compare it, measure the distance from that to the start of the circle, from the center of the circle, and see if it's less than or equal to the radius, because then, like, you know it's inside. Otherwise, if it was over here, the distance between that and the center of the circle is bigger than 1, so it must have been outside. That's how you keep track of whether it was outside the circle or inside the circle, and that's how we keep count. So if, and then how do you do that distance? It's what's the equation for this circle that's filled in like this? It's like and the distance itself is going to be x squared plus y squared equals 1 is the circle itself. But if you want the filled in disk, it's less than or equal to 1. There. That's the equation for the circle. That's if this is true about your xy coordinate is within the circle or on the edge. Okay? I hope that makes sense. It's just about the distances. So that is what we're going to program. If that is true, if x squared plus y squared times x plus y times y is less than or equal to 1.0, then it was inside the circle. Let's add 1 to our count of the darts that were inside the circle. Equals darts inside the circle plus 1. Boop. And then, like, all we gotta do, after we've thrown 1,000,000 darts, this loop will stop. And I want to print, I want to do some math now. I want to take the ratio of the darts that were inside the circle, so divided by the number of darts total, is that's going to approximate pi, divided by total darts. That's pi over 4. If I multiply that by 4, then that will give me an approximation for pi. And it's random, so it's going to be a different approximation every time, but it's going to be somewhat accurate. It's not the most accurate approximation. It takes a while to do it well. But if you throw 1,000,000 darts, it really will give you pi. So like this is accurate to 2 decimal places if you round it, 3.14. If you run it again, like it's gonna give you a different approximation. That's a much better approximation this time. Isn't that fun? So let's throw, I don't know. The more darts you throw, the better it gets. So let's throw 10,000,000 darts. Computers are fast. Yeah, 10,000,000. That might give us another decimal place. So that takes a while. It takes 10 times longer. But we might get a better approximation out of the deal. Oh yeah, look, we got 2. 3.1415-ish, or 16. That's 4 decimal places. That's beautiful. So yeah, that is an approximation of pi and using randomness. I hope that was fun. Any questions about this code? Just a fun application of the random library, I would say. If we're happy, I just want to keep going with some more examples of like functions plus turtle plus maybe some math too. So that'll just combine everything that we know, and that'll be a good place to end. So let's see. Let's do target logos because I don't know. I went to UCSB for 6 years, 6 long years, And near UCSB, there was no Target. Like, you had to drive to Ventura, like 45 minutes away if you wanted to go to Target. It was disgusting. The only thing there was a Kmart. It was the highest grossing Kmart, the second highest grossing Kmart in the country after one in Hawaii, because there was nothing else around. And that Kmart was horrible. So I'm going to pay homage to Target by drawing their logos a few times. Okay, they finally made a Target before I graduated, though, and it took the place of the Kmart, which is hilarious. So all's well that ends well. So, okay, let's make a rectangular Target logo because that's easier. All right, so we're going to need some functions, and that will help us a lot. All right, so let's say this. If we had this function that drew a square with a certain center point, a certain width, or maybe like radius, I should say, a certain width for your square, and then also a color, you could draw this Target logo. Because, let's say, apparently, if you do it in order, right? You drew this big square first, and you color it red, size 200. Like, here's the center of all of these. And then if you drew a white square inside of that after that, right, it would fill it out. And that size 125 apparently works well. And then if you drew a red square over that, a much smaller one, of size 50, width 50, see how that would give you a rectangular square-like Target logo? That would be nice. So let's make a draw square function and just call it 3 times like that, and that will give us a Target logo. And then we'll make it circular as well. All right. New file. I'll call this Target Square. And we're going to need the turtle library, of course. Import turtle. I don't think I need the random library for this one. That's just going to be all hard-coded. But we want our turtle to look like a turtle. So we'll do that. And yeah, if I just had this draw square function, I could draw this Target logo with these exact things by calling it like this. Draw square. It's always, let's just draw it in the middle, so like center 0, 0. And then the width for the first one is going to be size 200. It's going to be red. So draw that first, and then draw a 125 white square inside of that, centered still at 0, 0. That will overwrite some of the red, right? And then a size 50 red, also at 0, 0 after that. If you do that in that order, it will give you this. Okay? The order is important. Don't draw the bigger squares after the smaller squares, because they would be overwritten. But this is like hollowing out the big red square, kind of. So there's that. And now we just got to make the draw square function. So we need to pass along these 3 things. The center point of our square, the width of a side of our square, and then what color we want it to be. And we'll go and we'll draw it. All right? So I'm going to make a draw square function. Def draw square. It's going to take a center point, a width, and a color, and then we're going to go and draw stuff. So I kind of need the x and the y, right? Because to draw a square, like we need to get to a corner. We don't start in the center. We don't tell the turtle to start drawing in the center, right? We got to like move over. So like if we were size 200, we got to move over half of our width, right? Go over 100, then also go up 100. And that'll bring us to a corner of our square. Yeah? Does that make sense? It's like we got to get the upper left coordinate. We need the x coordinate of the center and the y coordinate because we got to do some calculations. So let's call it UL for upper left. UL, what is that? But like our x coordinate, our center's x coordinate, minus half of our width, right? Go that way. Get to there. Minus width over 2. And then our y coordinate is whatever this one is, but like also move up this way. So minus 100. Or sorry, go up, excuse me. Plus 100. Plus in the positive y direction. Half of our width. Center, that will always work. Center, if I can write center. Y plus width over 2. So that coordinate, if I had these 2 variables, would take us to here, right? So let's extract the x and the y from our center argument. Center parameter, I guess. So center x is, because center is going to be given as a tuple, a pair of things, which looks like, it's kind of like a list. You can think of it that way. So the first thing of this list is our x-coordinate. The second thing is our y-coordinate. So index 0 is our x. Index 1 is our y. Yeah, that's center of 0. And then that means center y is going to be center of 1. That's both pieces. And then let's calculate our upper left coordinate. UL equals center x minus width over 2, comma, center y plus width over 2. There. And now, let's get the turtle in formation. Let's have the turtle go to UL. Take him up, though. Turtle.up. Turtle.go to UL. And then turtle.down, because we want to draw stuff now. And we'd like to draw a square. So maybe we'll like make sure the turtle's facing right or east so that he can like draw that top part first. So we'll say turtle dot set heading. It's 0 for face right or face east. So we'll do it that way. And then we're at the top. We're at the top left. To draw the square itself, we got to go forward, right? Turtle dot forward by the width. And then, so then we did this, right? Turtle forward width will get us here. Then we got to turn right 90, go forward by the width again. I think you remember how, right? Turtle dot right 90, go forward by the width again. And then just like keep doing that, right? That's the second side. There's the third side. There's the fourth side. So that'll give me our square, but we want to fill it in. We want to fill it in with this color, so we'll set the fill color. Turtle.fill color to be whatever the color was that was passed to us. We're just going to make it red or white, but it could have been anything. Draw whatever color target logo you want. But set the color so that the turtle knows to fill stuff with that color. And then we also have to tell, as we draw a like closed off thing, we have to tell the turtle like, hey, I want this filled in, please. So you say turtle.begin fill, begin underscore fill, and then turtle.end fill in between the start and end of drawing that square. And then it will be filled in with that particular color. Okay? So that, in a nutshell, is our target logo drawing program. If I run this, I'll draw those 3 kinds of squares filled in, and it's beautiful. Any questions about how that's working? Yay. So it seems to be happy. It'll be the same one every time, of course, but hopefully we're seeing it work. It's drawing a square. This is some arbitrary square with a certain center, width, and color. And we're drawing these 3 exact kinds of squares. First, the big red one, smaller white one inside, smaller red one inside. Cool. So we did it. Any questions about that before we make a circular target logo? Alright. Let's steal all this code. I'm going to make a new file because we're going to make it better anyway. So circular target logo. I am going to make a new file. I don't know. And save it. I'll copy and paste everything and I'll save it as, I don't know, target improved would be a better target logo. More circular. And then also we're going to make the code a little bit cleaner. So there's that. So this is just the same program, copied and pasted. And then let's do it circular. All right, so what does it mean to do this? We'll make the same kind of program, right? But we'll make a, we'll use a draw circle instead of a draw square. Does that make sense? So let's do it this way. So instead of saying draw a square, boop, yeah, there's a comment out region. I love that. There. Commented that out. I'd rather just do it myself. Number sign, number sign, number sign. I am a bit concerned that it's not like coloring that in properly. Here, let me close it and open it again. Something was wrong there with the editor. There, now it's red. Much better. So if instead of doing this, if I had this, it would be pretty much the same if I had a draw circle function, right? A certain width. Really, the width would be the diameter, but let's not worry about that too much. If this was draw circle instead, if only I had this, right, it would draw that kind of target logo. Boop. So let's make that. let's make a draw a circle function. It's going to be very similar to draw a square. Copy and paste it and call it draw a circle instead. So draw a circle. It takes a center. It takes a width and it takes a color. And to draw a circle with the turtle, there is a function for that. There really is. It's called, where is it? I think it really is just called dot circle. There it is, turtle dot circle. You give it a radius, and you give it how much you want to do it, radius and an extent. So you want to always pass along. Let's see, what did I do last time? Okay, if you don't pass along either of these, you can just give it one argument, the radius, and it will draw a full circle. That's perfect. That's what we want. But the weird thing is that it draws it in a different way than you would expect. So this draw circle function, the turtle needs to be, for drawing circles and calling this turtle.circle function, you have to be not in the center of the circle, you have to be at the bottom. So you got to put the turtle right here, and then tell him to draw that circle with that particular radius, and then he'll do it. But it'll draw it above him, and it'll come back to the spot. So that's how that works. So you got to go from the circle's center to down here, because you're being past the center, right? You got to move the turtle to here, calculate this coordinate, and then that'll work. So we're passing along the width still, and that's really the diameter of the circle. So go down the radius is go down width over 2, and then that'll bring us to here. What is the coordinate? Well, you have center x again. We actually are not moving in the x direction. It's the same x coordinate. And then center y is down in the negative y direction by width over 2. So it's take your center y and then subtract width over 2. And if you get here, draw your circle of that radius. It will do it right. Okay? Let's make that happen. So apparently, I don't need UL anymore. I need a starting point, like the bottom of the circle. Starting point, let's call it that. And so it's the same x, and it's center y minus width over 2. So go there. We're calling it starting point this time. Go there. Set the fill color still, but just draw a filled-in circle. It's turtle.circle of a given radius. So the width is the diameter. The radius is half of that. Yeah? So that's your draw a circle. And if you just draw that, call that 3 times, it should be happy. Whee, there it goes. 1, 2. That's so satisfying. It looks exactly like a Target logo. So that is the circular Target logo. Are there any questions about that code? It's very similar to the square one. So naturally, we have to do a triangular Target logo, and then I'm going to talk about something. So let's do it like this, which does not, let's look like a warning sign on the highway, but it's the same if only we had a draw triangle function instead of a draw circle function and a draw square function, then wouldn't that be nice? Yeah. So yeah, let's pretend we have it. Wouldn't that be great? Let's see. Yeah, I want to do that first, and then we'll talk about it. So if only I had to draw a triangle this time. And width doesn't really make sense for triangles, so let's pretend like this. The width is the base of the bottom thing of the triangle. The width of every side, let's say. Okay? So if only we had that, then we'd be happy. So let me copy and paste the draw square function. Turn that into draw a triangle. And there's a pattern forming, and I want us to notice that. So apparently, to draw this triangle, let's pretend like the width is like the width of every side. We're given the coordinates of the center of the triangle. I had to look this up, and a student helped me in a previous semester. To get from the center of your triangle to like the bottom left corner, apparently you go down a third of the width of the side, and then you go over, of course, half, right? This is 1/3 minus a third of your width. That gets you from the center down, which is a little weird, but this is your bottom left. Center x minus width over 2, and then center y minus width over 3. I guess 3 somehow, because triangles have 3 sides, maybe, I don't know. But that's how that works. And so this is like not UL, but BL, bottom left. Boop. And so there's that. And let's go to BL, fill it with our color, and to draw a triangle, it's forward by your width. And if it's an equilateral triangle, it's turtle dot left, not 60. That's the inner coordinate, inner angle. It's 180 minus 60. Right? That is, because like this, we got to go here, turn by that much, which is like this is 60, but this is the rest, 180 minus 60. Those are what? Either complementary or supplementary angles. I don't remember the word. Maybe you do. And then you just do that a couple times. Once more. I'll give you a triangle. Alright? So hopefully that makes sense. I'm going to call that in the same way I've been calling the other ones. But there's the draw triangle code. I'm going to call it 3 times. Oops. Pasting from PowerPoint sometimes puts in weird characters. Now it should be happy. And there we have a triangular target logo. Very similar to all the others. Any questions about that? Alright, because there's a pattern. There's a pattern here, and we need to talk about it, and that will be that will make everything better. So like instead of doing all this, do you see how all of these calls to draw these target logos are made exactly the same, right? It's just change the name of the function, right? So there's some more generalization that could be done, okay? We can make a function not like this. We can make a not a draw square function or draw circle function or draw triangle function. We can make a draw target logo function that takes which kind of target logo we want by passing along, like, do you want to use the draw square? Do you want to use the draw circle to draw their sides? Do you want to use the draw triangle to draw all the pieces? You can pass the function itself that you want to use as an argument to another function, which is kind of wild, and it's just amazing, okay? So we can use functions that take functions as parameters, and that will let us do this. We can be like, draw a target logo using squares, using draw square, and center that logo at 0, 0. Won't that be nice? We can pass along which kind of target logo we want to draw by passing along the side drawing function. Won't that be cool? And here's how this will work. We'll call that function, whatever it is, we're going to take it as an argument, put it into a variable. So def draw target logo. This is like the coolest thing. I don't even teach my CSCI 40 students this idea. Center, draw shape. What is this? What is the second argument, this parameter, but another function? Like we're passing on which kind of shape to draw. We don't know which one it is. We're just going to use it. So that second thing was a function. We're going to say draw not square or triangle or circle. We're going to say draw shape 3 times. Whatever that was that we got passed to us. Draw shape. With those centers and things and colors. The center could be arbitrary, so let's have the user pass that to us, not necessarily 0, 0. But if I do this, if I run this, it'll jump to here, set the center to 0, 0, and use the draw square every time it says draw shape. It's going to call draw square because that's what I'm passing along for that variable. It's just a function. It's using it as it is, as a function. Isn't that lovely? So there's that one. And then we can do the same with the other ones. We can make a square target logo over there. We can make, or maybe we can make it small and up here, 150 by 150 target logo. Over there, we can make a circular target logo at negative 150, negative 150. We'll pass along draw circle for that one. And it'll just run that. That'll be its draw shape function. It's going to be passed along. We'll just use it. And then draw triangle somewhere in the middle, let's say. Let's do 0, 0. Draw triangle. Do you see how this is much more generalized now? Instead of saying this 3 times, that's a little clunky. Just make a draw target logo function, and you can draw any kind of target logo by passing along your shape drawing function as well. It'll call that for you with the right argument. So there it is, making the square target logo. There it is, making the circular target logo. And in the very middle, it'll make the triangular target logo. Beautiful. And that is the beauty of functions. You don't have to pass along just numbers. You can pass along other functions, and you can call those other functions whatever they were. This ends up being draw a square the first time, draw a circle the second time, draw a triangle the third time you run this. Does that make enough sense? It's kind of logical, I would say, but you're not used to it, I don't think. So that's that. It's a good program to study, I think. Any last questions about that before I move on to other completely different things? Just like the finale, I guess. And if we're happy with that, very cool example. We love Target. Here are just a couple fun examples that you will have to read the code yourselves because it's long, and I'd be happy to explain it to you sometime if you would like. But it's like using the turtle module to do cool stuff that is a little bit more complicated, but you're ready to understand it. So have you seen these kind of artworks, like the things done by Pete Mondrian? I think that's how you pronounce his name. You can use the turtle library to make these randomly. So I made a program that draws pictures that look like this. And once you break it down, it's not horrible. Like, here's the idea. Here's the setup. Here's the algorithm to make this. What I did is I made, first of all, I told the turtle to draw a bunch of thick lines. I'm going to draw a bunch of lines everywhere because those will be outside of everything. And then I'll tell the turtle to draw 6 random, oops, that's the first. Tell the turtle to draw like 6 random vertical lines and 8 horizontal lines because it's a bit taller than it is wide. And then we're going to start picking where to draw these random squares or rectangles. The idea is you pick your lines. Like, to draw this red square randomly, you just pick, like, here's the first line, here's the second line for horizontal lines, and here's the first line and the second line for vertical lines, and it'll, like, draw a square in between those lines. So long as you do that randomly, just pick 2 of these lines, pick 2 of these lines, and draw a square between them. That's pretty much it. Does that make sense? That's the algorithm. Repeat the following. Pick 2 random horizontal lines, 2 random vertical lines. They form a rectangle. Color that rectangle one of the colors that the dude used, and then crop off the edges eventually. It's just draw a rectangle used in a very fun way, I would say. You know how to make that function now. So here's this code. I won't show it to you for very long. You can look at it yourself. But it's kind of cool. PeteMondrian.py. And so it's draw a rectangle, but a lot of other stuff too. Picking random colors, picking random vertical lines, horizontal lines, drawing those lines. And then I'm going to ask the user when they want to stop. Like, keep on going. Press enter to keep on going, or Q once you're done, you like the picture. So as long as you want to keep on going, find a random square to draw by picking 2 random lines that are horizontal, 2 random horizontal lines, and 2 random vertical lines, and then draw a rectangle between them of a random color. Then crop everything off. So feel free to look at that if you like. But here's the code itself. It drew some random things, and I can't even resize the window until I finish pressing enter and stuff. So type enter to keep on doing stuff. Can I resize this window? Not yet. So I'm just going to keep typing enter. It's drawing some random things, random rectangles between these things and filling them in. And eventually you're like, oh yeah, I like that. I'm done. Q for quit. And then you can finally, like, it crops it off and you can, like, look at it and use it as your phone's screen or something. Isn't it beautiful? So yeah, it's just randomness at the end of the day. And it'll work different every time. But that's that program in a nutshell, I would say. Wait, can I move this to here? There it goes. And so eventually it might look pretty and you can stop it then. There, Q. But yeah, it's going to make a bunch of those, and it's really just a bunch of draw rectangles randomly. So that's a fun little program, I think. Feel free to look at that. That's that one. I think you can understand it. And then, do you guys know this Joy Division album that people like to wear on their t-shirts? It has this cool picture on it. We can use the Python turtle library to draw this picture because the information that is used to draw this picture is public domain, surprisingly. So let me show that to you. And then while it's drawing, I'll explain it because it's going to take a while. Apparently, this album cover shows a signal that repeating signal that somebody read from like a telescope, a space telescope, and I can't resize it just yet, can I? It has to wait, but it's drawing. Give it some time. It's doing it. It's taken from the signal here. Signal from a pulsar, apparently. If you know what that is, it's coming from some black hole or something is emitting radio waves, and somebody read those radio waves. And then here is, oops, not that, but this. This particular pulsar. Oh no, go away, Wikipedia. And then if you take this period, I don't know, the period that it was measured, and you graph it, like sometimes the signal was high, the signal was low. Here's the signal itself, just a bunch of lines of it. It's like you just tell the turtle, like if the signal moved up, tell the turtle move up. If the signal moved down, tell the turtle move down, and just like draw a bunch of lines that overlap using this, and you will have recreated, well, using draw rectangle and like some draw polygon functions that I made. Feel free to use it. It's just drawing. It's using that data to like move the turtle up a little bit, move the turtle down a little bit for every piece of that signal, and yeah, eventually it will draw a very pretty picture, and it's going to match exactly this album cover, which is fun to think about. And it's just a bunch of code to do that. And yeah, so feel free to look at that. Now you know how to do it. There it goes. Can I move it while it's drawing? It's taking forever. It's a lot of information. So there it goes, but it looks exactly like the album cover because it's that same data. And you get the added benefit of the turtle appearing at the bottom right once it's done too. You don't get that addition usually. So it looks like it's almost done. It's got like 3 more lines to draw. See where it is. I think it finished. There it goes. And so then we got also, oops, it's very unhappy right now. It's a lot of memory. Can I resize you, please? There it goes. I think it's happy now. But you can see the turtle in the bottom right there. And I don't know if I'll get to resize it properly for you, but I think that's the idea. Let's see if I can click one more time. Oh. Yay! Okay, so there's your pretty picture. The last picture I'll have the turtle draw. So feel free to look at that file, give it to you, ask me questions about it. It's just another fun example of Turtle Land. So yeah, with that, we did it. We made it to the end of the class, everybody. Thank you all for putting up with me. Of course, I'll see you on the final day still. But before you go, one thing I do want to tell you is this class was made mostly to poison your minds in the hopes that you would become computer science majors. So please consider becoming a computer science major if you liked especially the programming stuff from this class and you already are not like a computer science or engineering major. So this is what this class is all about. We're trying to get you guys to secretly be a part of us and like be a part of the major too. So if you liked what you saw, consider it. And with that, I will see you later. That's all I've got.